Again, welcome everybody to the Hopkins Work Center tour event today. My name is Collin. I'm the program director for the data analytics and policy program here at Johns Hopkins, and I'll let our panelists introduce themselves in just a moment. I'm also joined today by Chris Kromphardt, who is the assistant program director for the data analytics and policy program.
My name's Liz. I'm currently a principal data scientist, and I work in the risk space. So we use AI, machine learning, other topics from our Johns Hopkins course in our day-to-day life. And I'm a proud Hopkins alumni. Great to be here.
Evan Anderson. I graduated from the data policy program in summer of 2023, and I'm on back at McKinsey, so I work directly with Gen AI.
Meet everyone. My name is Biscoll. I'm a senior product analyst in the program in May of last year, and right now I work essentially on projects making our own internal systems and processes more efficient and just help people to do what they're looking to do. One interesting program we're working on right now is actually adoption of various AI products and seeing where they're efficient. So we're just talking more about that.
And I'm not a panelist, but I'm the assistant program director of DAP. My name's Chris Kromphardt.
You have been recruited to be a panelist, Chris, by virtue of being
honorary.
Yeah. Well, thanks very much. I thought I would actually start the question by asking you all to provide a little bit more about your background in data analytics, sort of how you got into the jobs that you're in now, and sort of where the master's degree from Johns Hopkins fit in over the course of your sort of methodological training. Was that a way for you to sort of get into that industry, or was it more of a way for you to advance your career once you kind of had your foot in the door? I guess we'll start with Brett this time and work our way down this way.
Awesome, sure. So I guess my career journey, I was in a few different business analyst roles, so working on software development teams, and I think it was around when I started, I believe 2021, I was just thinking to myself, I want to have upskill a little bit. I enjoy what I'm doing, but just project.
I don't think we can hear you.
Sorry. This work? Yeah, perfect.
The loudest you possibly can.
Yeah, so around 2021, I was just looking to upskill a little bit. I'd always been interested in kind of the policy side of things. I dabbled a little bit in undergrad, but I focused on my major, which was finance at the time. So I was looking around at programs, and the data analytics and policy one was kind of the best match. Yeah, and I will say, I think almost everything I learned in the program came into play in some capacity, whether it was just kind of giving me a foundation for what I could work on or giving me the actual skills that I could bring into the program. So yeah, I think that's how the two connected there.
Yeah, so I did my undergrad at the University of Virginia with a major in foreign affairs and a minor in data analytics. I got kind of dipped my foot into the kind of statistics side of things there, and then decided that I wanted to keep going and get my master's degree. So I started the program pretty much right after undergrad.
I did not start out technical at all. I did my undergrad at the University of Michigan, and I studied anthropology, Spanish, and political science. So like very heavy in the humanities and social science of things. And then I ended up coming to DC and ended up getting a job in compliance and risk, and really enjoyed kind of the analytics space in that area. So decided to go pursue further education to become a data scientist specifically, and joined this program, graduated in 2022. And this program was basically the reason I was able to become a data scientist. Before that, I had no prior technical experience. So it was really cool making that transition kind of later on in my career versus earlier.
I actually would like to follow up with Liz on a question, and this might relate to the other two panelists as well. Do you feel that your transition into the data science world without having, a math or a physics background or sort of a more traditional data science degree or computer science, has that kind of inhibited you? Has it changed your career path? Or what does that look like when you're interacting with somebody who may have really deep mathematical or statistical background?
Yeah, I'll take that in phases. So in some ways it's been an advantage in that I felt like I built a lot of what I hate the word soft skill, because I don't think they're soft. I think they're really strong skills actually, in terms of like leadership, being able to engage with stakeholders, dissecting a problem and being able to break it down into its components to actually solve it. And in those areas, I think I had quite a strong skill set from my experience before being a data scientist. but it helped enhance the career as a data scientist because we have to do the same thing. We have to break down really complex problems into pieces of code or JIRA tickets or whatever the thing is that you use to actually implement a program. It also taught me to be very curious and ask a lot of questions. So I have members of my team that are career engineers, physicists, and mathematicians, and they are infinitely smarter than I am. But I find a lot of confidence saying, like, I don't understand this and I really want to. Could you help me break this down into more digestible pieces that I can tackle? And it sets the foundation for actually being able to learn much more complicated pieces of code or mathematical problems or algorithms or whatever it is we're building. So drinking from the higher fire hose was definitely my experience the first year as a data scientist, but I feel like it actually, like those softer skills helped me build to where I am today. Yeah.
Evan, I don't know what kind of interactions you two have with sort of the really technical side of things, some sort of IT or systems building side. What is your sort of interface with folks who may have a different disciplinary background than you do?
Yeah, so on the team I'm currently at, I interact a ton with software engineers. So there's definitely been some having to go through tons of YouTube videos and kind of really learning the nitty gritty of stuff. But I would say that a lot of what we do is just critical thinking and experiments as well. So like reading poli-sci research papers and kind of just trying to understand causation, and that those skills definitely translate. And so we're all kind of speaking the same language, but definitely had to watch a couple YouTube videos too. And the comp sci part of things that went right over my head at first.
YouTube Academy is like the best,
Yeah.
really.
I can kind of echo the same thought. I work with software developers. I work with kind of everyone across the board, and there's very much, if you have all the technical skills and you can't work out the business case, you're not going to be able to do anything. If you have the business case, no technical ability on your team, you're not going to be able to do anything. So you really do need to take both approaches. And I think, there's value in kind of, I don't want to use the term like soft skills.
I know,
Those
I
other
need a new word for it. Yeah.
strong skills,
Strong
those other
skills.
abilities, and kind of the being able to understand programming, understand data, understand like what is actually feasible and what you're doing. It takes both components to make a project.
What do you all think about, there's a sort of an issue of nomenclature out there, right? You have data analysts, data scientists, software engineers, data engineers. Like, where do you see those sort of disciplinary lines drawn? When you're actually in the field, are they sort of sharp? Are they softer? Sorry to use that word again, but what is your sense of sort of the distinction across that range of job tasks that are out there when you're thinking about big IT data science systems? Buddy?
So, in my opinion, my experience, it really does seem to be kind of a fuzzy barrier for some of these titles. You really do end up getting pulled into kind of every dimension of a project, but it's really based on the team. I think there are some roles that should be followed, like QA should not be on development, things like that. But aside from that, you work in any phase of the project, you should be flexible enough to do that. And over the course of your career, you probably will end up having kind of that cross-team experience. So in my opinion, it's very different.
I would say the same thing. I mean, there's a ton of overlap. I would say if you're looking for a role, I would look at the tech stack and kind of what the actual job description says, because the role could be advertised as a data scientist, but it could be heavy on software engineering. And then same thing, other way around, it could be a data science role and it's way heavier on data analytics. And so because everything is moving so fast, there's a ton of overlap.
Yeah, I echo what Evan said. I would say, like, always look at, if you're thinking about it from a job application standpoint, like, what am I qualified to do? What skills can I take into this job? I think it's much more important to look at the description of the role and what the expectations of that role are over the title. I think data analyst tends to get a feeling that it's a more junior role, and that's just not the case. It's just a different skill set than maybe what a data scientist would do versus what a data engineer does. So in my role specifically, I cross between data engineering, data analytics, and data science on a daily basis, depending on the project and the need and scope, which I like. But some people prefer a much more clear delineation between the two. So I think it really does come down to the role description and what you think your capabilities are in response to that role. Yeah.
I wonder, it might be helpful to the audience, and I know there are some, obviously issues with confidentiality with both within your organization in terms of your clients, but I wonder if you could give a sense of, what is a sort of a common data science task that you might be doing, that your team might be working on? What is, speaking very generally, what kind of systems might you be working with? Like, what is the data science work on a day-to-day basis? I mean, are you firing up Python? Are you just responding to emails and doing managerial things? Like, what are some of your day-to-day tasks, like right now, and maybe what were they maybe earlier in your career too?
So the way I fit within our organization is I'm an equivalent to like a senior manager, but my title is principal data scientist too, for what that is worth. And so my role, I manage a team of people. I have 3 people underneath me, and we work on various projects together. So I would say in my capacity today, it's a good mix of people management as well as stakeholder engagement. So I need to go out and actually identify either what projects we're going to work on, or within our projects, what the scope of those things are going to be. And that takes up a good chunk of my day. In terms of actual keyboard time, like what I do day to day in terms of coding, the gamut, like Python, R, SQL, Excel, sometimes, honestly, and then the various packages within them. So that's probably like a very loose overview of what my day looks like.
Yeah, so I work on Lily, which is the Gen AI product of Kinsey. Essentially, day to day, I'm more on the product side of things as a data scientist. So if there's a new feature, I either build out the feature myself or a software engineer does, and then we do testing, right? So there's a lot of, does this get us, we have a set of metrics. Essentially, it's kind of the core data science pipeline. We make the change, before and after the change, how does, do we move closer to our goal or further? And essentially Python every single day. So if you're taking Unleashing Open Data in Python, pay attention, because, and if you want a similar role.
Collin taught me Python, if you want to find that. Oh, yeah.
Well, good news, everyone. So a lot of that class has actually been merged into programming now, so they are required to learn both R and Python simultaneously, because that goes to a point, I think, of being, I hope you will all agree, being able to be multilingual is really, really important in this day and age, and it's not that different. So if you have anything to add on that, topic of the day-to-day and what you're working on.
Trying a little bit to yes, I'd echo the same thing, being able to work or at least understand bits and pieces of R and Python. Those are always very useful. Try not to get too into the nitty-gritty, but one thing I've noticed is that a lot of the time you'll get a request, and it'll be, we have data set X, can we do project Y or find insight Z? And you go to the data set and it is incomplete or messy data, or it's coming from different places or different things, or it's just things don't make sense. And that's one thing that I noticed, really getting into the business world a bit. You really have to be able to kind of work with what you have, figure out, and when you're standing things up, figure out how to get clean data and how to operate with it. Because it's just, in reality, it's just not going to be perfect 100% of the time, usually something much less than that. So,
very open to questions from the audience. Yes, sir.
Yeah, so data scientist, do you see yourself as a scientist?
Whoa.
I can answer that. So a lot of my work has to do with LLMs, so large language models, so like GPT and whatnot. And so you actually have to read research papers that are from like Stanford and the big, like all the big tech places. So there is, I'd say the skills from the capstone definitely came in handy as far as like being able to sift through academic and scientific research on the subject. And I mean, that goes into the debate of computer science is, you're a scientist or not. I would say yes, but yeah, I think it's pretty close.
I tend to agree with that. I think a lot of our day is spent, at least a lot of my day is also rolling documentation. So it's more about, I have to build something, I don't know how to build it. I have to go research how to build it. I have to make sure I'm using the right technology, using the right method. I have to go talk to other people involved to ask if I'm using the right data. I have to know how to manipulate that data. And then I have to be able to generate insights and explain if those insights are concrete or need further investigation. That's, if you think about it from like what scientists do. In that sense, I would say yes. If you ask me to do biology, heck no, can't do it. Yeah.
Chris, do you actually have a thought about that as you kind of moved a little bit more in your career towards the sort of the data science thing? Where do you think the science comes in when we're doing data analytics? Sorry to put you on the spot. I think it's a very interesting question.
Yeah.
No, I think it's a fantastic question. And I mean, it's a little bit in the eye of the beholder. It's like if you unpack the process of science, and it is more of a process rather than you have to use these particular data for this particular objective. So it is a little bit how you define it, like the particular tasks associated with it. It might be reading paper, it might be papers, synthesizing papers, understanding data, might also though be doing experiments. And I was wondering if you have any experience with that yourself, or people that are a part of your teams, like the actual designing an experiment with an intervention, maybe to be precise, designing an experiment, collecting data from a sample with an intervention, trying to understand the output. Do you have any experience with that?
Yeah, I mean, I guess very generally, product design is very important, and being able to kind of understand like what you have to build out certain business need. It's just kind of foundational. And again, it's those being able to actually manipulate data and understand it and being able to read what you have. Because when you just look at CSV, it can be kind of daunting or not clear. It's just kind of one of those. I guess that was super technical. But
Yeah, so data. So being on the product side, you kind of know where your data is coming from. So there's a lot of that. I would say we definitely use the core data science skills. But it's a little different from like site research. We're doing that kind of thing. The experiments are more gold versus like when you do site experiments. There's endless amounts of things that you can't control for it. So there's like,
I think about like the program projects we did, for example, where like if you were conducting research, one of the things I worked on was analyzing congressional data insights. And so just trying to understand like sentiment on a congressional briefing. Like I got it wrong. I got it so wrong. The accuracy of my model was like 20%. It was bad. And so I had to figure out how to like improve that, how to iterate on it. Was I using the right model? Was I using the right package? Was I formatting in a way? What was my feature engineering like? Like there were a lot of decisions that had to be made. And even if I got the accuracy score high, they were still based on my own assumptions, my own biases. So it would need further interpretation and research to actually generate useful insights versus like my semester long attempt at wrangling data. So I guess like I'm sure you experience it in political science all the time. You're like, I need peer research and further insights to be able to actually generate a useful result.
Yeah. And so like useful result, again, kind of in the eye of the beholder, would you say like the objective of the research, is it more prediction, classification, causal inference? Like what do you find yourselves doing in a typical week?
Varies. I hate to say that, but yeah, for me at least it varies all the time because I work on so many projects at a time, so it can move quite quickly. I would say like causal inference is probably the most often one, like why is this affecting that? And then what's the resolution to it? But I don't necessarily work in a lab space like day to day, like based on what it does.
yeah, I would say causal inference is probably the number one. So A/B tests and whatnot.
Yeah.
Because it's for us when we roll out a new feature, you're essentially testing what changes and what doesn't. So there's a lot more of that than just, I suppose it's prediction, but it's more A/B testing, kind of. That's the old.
it's the same thing. I mean, just when you see a change in like the data that's coming in, that's representing, user behavior, again, very high level. But you want to understand like what's causing this. You want to understand it's good behavior. How can we promote this? It's negative. How can we kind of block that? And that's very much, that's very experimental and kind of getting into the weeds and very business case focused. So, yeah.
I think also like we're coming at it from a consulting lens. So our day-to-days as data scientists in the consulting space is going to be quite different than maybe a data scientist working at a research center in biotech or someone working at Netflix trying to analyze like user inferences and stuff like that. So I do think your industry can largely affect like what you do day-to-day in this space. For sure.
Sir.
A couple of related questions. I hope they are data science. So I was at World Bank summit last couple of days. It's on transforming transportation. And I did a sort of LLM of the whole agenda before I went. And it was pretty good, except the one subject which actually Bloomberg Philanthropy has contributed to this in 25 cities, 15 countries, which was actually half the whole day, wasn't included in the way the LLM thought. So my question there is, when an LLM is missing something, is there some kind of sort of way you can plug in all these cases? I mean, you know, there are hundreds and hundreds of cases, if you like, in this sub area of transforming transportation. So how do you get that into an LLM that is missing it? The second part of that is that over the 2 days, and I think it's interesting because I spent all my life, I qualified as a statistician at Cambridge's maths lab, 40 years ago, but I've done lots of huge data surveys in the old days. Now, the problem in the old days is finding the code you really need to answer a question, and it's often not there unless you do, let's say, qualitative research early and make sure. Well, apparently, for 15 years, all of transforming the sort of, if you like, all the ticketing of buses and car rides and all of this, completely misunderstood women's transport across cities because they didn't ask the basic code is, are you going to work? Are you off for entertainment? Are you over? Now, when you do that for men, that's apparently enough. But what they missed was the 40% of all women's trips were actually to go and care for another member of the family. And so without that, so there's a Harvard professor who's now the last 10 years sort of started putting that in, and that completely changes the whole value design of transportation systems. So are those data science questions, and how do we cope with them if they are?
Maybe you can raise your hand.
Yeah.
I can answer the first question. So the bit about if an LLM doesn't have enough information. So there's a very common methodology now called retrieval augmented generation. If anybody's heard of that, RAG, the guy who invented it, does not like the title that he gave it. Talk about bad titles or not. But essentially what it does is it's a text search. So you have a bunch of documents, you use a search algorithm for the documents, and then whatever that search algorithm comes up with, similar to how like Google works or any of the search engines that you use, the LLM then bases its answer off of that text. So this is pretty common. There's if you've ever used Google, now with Gemini, you type in a question and then it's vector search or whatever type of search they're using, takes all the web pages, and then Gemini is just that kind of final layer on top that creates the answer that you need. So that's one of the methods. There's a lot. The space is growing very quickly, but the finding information that is the most recent relevant information is a difficult problem that a lot of data scientists are trying to tackle right now.
If, for example, you know that it's missing thousands of cases of a particular sort, is there a way to put that into an LLM?
Yeah, I mean, if you know that those cases exist, you can certainly upload it and then have the LLM do it. But if you're from a product side, I can't. I'm assuming the user doesn't already have that information. So I'm hopefully, as a data scientist, creating tools such as RAG and others to make sure that they have the most updated documents. Answers the question right.
And your second part too, I think.
Yeah, just to touch on the product side of things, I think that highlights for LLMs. There's a lot of interest. They're very powerful tools, but they're not 100% perfect or accurate. They're based on what it's fed into them. So the value of domain knowledge is still very important. someone who isn't thinking of that would just take what the model is spitting out as gospel. That's not, I think, the route we want to go to. Only people to kind of use the data, understand things, think critically, and like, is what I'm feeding this correct, incorrect? How do we go about getting correct information? So just to highlight this, still need people to think about these things.
There's entire courses taught around LLM prompts now too. Like, what's the right thing to put when I'm looking for an answer? What do I put in? And they teach you to tell the LLM, don't make this up, because sometimes they will, just because that's what they've been trained to model. But to your second question, like, would that be considered data science? I love that study, by the way. I saw it, and I think like one of the things was women pushing prams was like one of the things they hadn't considered. And it is data science if you're thinking about it in terms of like making a decision or a change. Like if the question was, how do we make transportation more accessible to like the general population? Using that paper would actually be really useful to figure out how to do that either on buses or walkways or roads or whatever the system is that we're looking to update. Yeah.
And in a sense, it was worse than that, in that there were huge databases of cribs and that, but you know, it wasn't coded by the one thing that would have shown the value, a completely different value than all the other analysis would show you. So I think it's really interesting. How do you get to missing code sort of thing?
Well, I would just like to add one thing and then jump to your question. I think, again, I'm not a practicing data science in my day-to-day. I'm still an academic, right? At least for a little while. It's still a little part of me, at least. But I think it's important to remember that data science is still about human behavior, right? And so you're trying to you're trying to capture as many aspects of behavior as you can and make strategic decisions about what you're going to measure, how you're going to measure it, and what the problem is. Because like Evan was saying, I mean, the LLM only knows what you give it, right? I mean, it only has the classic garbage in, garbage out. I mean, this is still true, and it's going to be true for the rest of time. So when people say software engineers or data scientists are going to be obsolete because I'm just going to, I'm going to create an agent-based LLM that's going to do my work for me, I don't think we're anywhere close to that because of the need for sort of critical thinking. And that's one of the reasons I may pitch the degree for a moment again. We're really trying to blend, having the skills to use those tools, but also the sensitivity to be able to read and understand the world and bring those two things together, because there's things that pure data engineers may not appreciate about the dynamics of human behavior and organizational behavior. And that's the sensitivities that I think are, from my perspective at least, take you from sort of someone that could be replaced by an LLM to someone who is irreplaceable in any organization. Anyway, that's my pitch. There was a question over here. Yes, ma'am.
To piggyback off your question and add on to that, I actually took my master's in communications through Johns Hopkins in 2019 alum, but interested in kind of that intersection of other disciplines and working with people that AI and data science is their primary what they do day in and day out, and how they complement each other. And so I think the question about what's missing from the data is really survey design, and in that program it's a whole class, but certainly a large portion of one of the graduate classes is how is that survey designed, and are you really asking the right questions? And ultimately you need to be familiar with, at least you might not know all the questions that you're asking at the beginning, but familiar enough to know that you're going to ask enough information so that your data set has enough information for other team members to then analyze it and get the information that you're looking for. So I guess from your day-to-day, do you feel like I've worked at an organization as we're trying to implement AI. We're very much working in silos. I've most recently been in marketing communications for a financial institution. We have our IT team trying to use it. It's all very disconnected. And so do you feel like, at least the organizations that you're at, that there's kind of an overarching goal and vision for how these departments and teams work together so that no one is working in silos, and that the data does have inputs from subject matter experts?
From the risk side, absolutely. You have to work with subject matter experts, because if you're making a business decision on, am I going to do X versus Y because of this present risk? I, as a data scientist, don't have the expertise to tell you what decision to do, but I can give you data to help feed your decision and make an appropriate response. And in those instances, I have to work with subject matter experts because I just don't have those insights on my own. It's a really simple way of answering it, but yeah, in my space for sure.
Say the same thing. So I'm a technical person, and so I don't know what. There's a lot of different sections of the firm. No idea about essentially life, like talk about biology, for instance. So you definitely have to work with subject matter experts and kind of get the perspective on a product that they're going to be using.
With that, I think there's definitely a top-down strategy. I will say I think there are varying levels of adoption from team to team for usually very justified reasons. Either they're very sensitive to security risks with their information, or they simply don't have the bandwidth to start working on this new project. So it really has to be, you have to coordinate across teams, be mindful of what they're looking for, be able to address their concerns and kind of prove the utility of these tools when you're putting it into place.
This is where it's good to have like product managers versus developers versus QA testers, like, and then also SMEs as well. Otherwise we'd end up probably like, my data's great, I'm validating it myself. It doesn't work.
This is perfect, ship it.
Yeah, exactly. Go for it. Push it to prod. So
I have a question for the people in consulting. So my main question is there a discernible difference between public sector like consulting projects and private sector consulting projects? That I just want to understand, like, you know, are they asking for different things? Because a lot of people say, you know, government's 10 years behind private sector or whatever. Does that come out in the data science space? Because I know the government is making a lot of investments towards data science and AI and all of that. And so just as far as like your personal experience of working with both sides of clients, if you have, just talking about if there is a discernible difference, what it is, and how you kind of blend the two together and how you can use things from one sector to another.
You worked on private, public. I don't know what the.
I have worked with varying different data sets. I don't think I can go into much detail, but I mean, there are different rules, there are different levels of, you know, regulations around this, like what you can transmit, and that does impact what you're able to do with it. That's not a reason to ignore any rules, not make a process around it. It's just a reason to develop that process. Like if you need to de-identify some data, you just have to work with that and either use another thing to identify entries, for example, or just work without it because there are just limitations around it. So I would say I don't think I've worked with public sector data too much, but like, yes, there are differences between the data you work industry and field to field. You just have to kind of approach each one as its own situation.
in some ways, at least from a data availability perspective, I feel like public sector data has more available data. Like HHS publishes things, Congress publishes stuff. So like depending on the project, sometimes with public sector, it can be easier to actually like get the insights you're looking for in terms of like how quickly you move or, you know, bureaucracy, how that comes into play. It varies dramatically. But you're right, there's huge investment in public sector in the data science and AI space. There was the previous administration, there is now under this administration. And we're seeing like cool advancements as a result of that, but it's hard to say like internally how it differs. Yeah. I hope that answers your question.
I know I wasn't one of the consulting people you asked the question. I hazard a response as well. And I think there's sort of two things. One is that, you know, and this is again from an outside observer perspective, but you're kind of optimizing over different values, right? If you're working for a public sector organization and you're doing data science work, then like there is, you know, it's a political process. You're deciding who gets what, when, how, and under what circumstances, right? And so you're trying to think possibly more about sort of what are the outcomes in terms of the equity of your decision making. You know, how are these benefits distributed across people? Mm-hmm. Is it being fair and given in a just way in terms of like the substantive sort of due process of it? There's like other considerations that you might have that sort of might slow down your decision making in some ways because you have to think about that. The other thing I was interested in a comment you just made, Liz, about data availability. I kind of have the opposite opinion, but really? It may just be a lack of experience on my part, but I'm envious of private organizations that can really integrate data gathering across their entire organization at once, right? It's not as though like HHS data sets or CDC data sets are great, but it's very hard to collect information about, everything the federal government's doing just because it's so big. Whereas like a company, if you have a good data strategy, should be able to, suck up all those measures of activity in lots of different ways. So I mean, I've not worked in the private sector, so I don't know how difficult that is, but I sort of have a somewhat different reaction to what you're saying.
Maybe it's context difference, right? So like if I'm doing research, HHS has like such an abundant source of information that I can access to then generate insights. But you're right that a private organization, if you're measuring internal results, is probably going to have a very robust way of tracking their data to generate insights. So I think it depends on like what you're measuring, what the goal is, etc. Yeah. Like I don't think Michigan publishes like its HR stuff, but it's a public university.
Yeah. You have worked in the IT industry before you joined the program here, right? Yeah, the university. Okay, IT background. So someone that knows SQL, Oracle, SQL Server, report generation, and all that stuff. How much of a learning curve do you think would be there to pick up the skills, let's say, that the program offers?
I mean, what is the learning curve between knowing SQL and coming in?
Yeah. You let's say you have IT background, you know SQL, you know how to generate reports and work with the databases and all that stuff, Oracle, SQL Server, etc. Right? So the skills that you gained after joining this program, how much of a learning curve was there for you? Was it relatively easy for you because of your IT background?
I had a pretty easy time. I think I had maybe just a little bit more technical skills than
Me.
a lot of people coming in, but I think they do a very good job kind of building the foundation and kind of easing you into it, getting you ready for kind of those later classes that are a lot more intense. Like I said, machine learning was probably the hardest one that I took, but I mean, the foundation is there. I think it's something anyone can get into.
You do a really good job at Dr. Robert Bird was the guy that ran the programming class when I did it. And he's brilliant. He works for Gallup, so he has insights both from the industry perspective, but also then the student experience. And he set it up in a way to learn R. I had zero R experience, never worked with it, like didn't even have it on my computer. And by the end of the term was able to basically create our Shiny applications and stuff in like 4 months, basically, which is crazy because I was not wired that way at the time. And same thing with the other skills. Like once you learn one, your brain kind of switches on to being able to learn the other. I think if you don't want to go via the program route, but I highly recommend you do. It's a really good program. If you don't go the program route though, and you're interested in like self-skilling, at least for me, the order of operation to like build up would be, again, that's my own personal journey, would be Excel, SQL, R, Python. I just found like that was a really easier way to build. And then from there, you can start learning more conceptual pieces and how to apply them to like real world applications. But I don't know if that's different from what you guys have done.
Yeah, I started out with R, and kind of moved into Python. Let's say once you kind of get, they're both, I don't know how technical you are, but object-oriented programming. Once you kind of start, once you start speaking that language, it flows pretty.
Learning how to read documentation was also really hard for me, but once you do it, it unlocks a heck of a lot of upskilling. Yeah.
So in your current role, if you're thinking about something that you're maybe trying to look around the corner, like what's something that you might be eager to learn and that you might share with the audience? And how might you go about doing that? You mentioned YouTube videos before. Is that?
Yeah, I mean, YouTube videos are great. There's, I don't know if anybody's familiar with Hugging Face. They're a open Hugging Face.
Like hugging.
Like literally hugging a face. I know in tech the names are really weird, so just bear with me here. It's called Hugging Face. It's where a lot of open source LLMs and NLP models are published, and they have papers and everything. And so it's kind of like GitHub of LLMs and generative AI work. I don't know if they also do YouTube videos, coincidentally, but that's a pretty good way to start. And, yeah.
Is there anything on the horizon that you might try to learn?
Mine's super uncool. I'm trying to learn Glue at the moment, AWS Glue. which is not a very like data science-y, it's very engineering. That's I'm really sorry for being such a blunt, but yeah, that's what I'm excited to get into.
Nothing in particular that I did learn about AWS through this class. That was really good.
Yeah.
That was really, interesting and relevant. But I would say with respect to kind of upskilling in general, like I'm kind of struggling to think of an answer because there are just so many resources out there in like any format you want. If it's like in a personal talking to someone, if it's just YouTube videos, if you learn better through, written word, there are tons of guides. So it's, anything you want to learn at any level, I feel like steps are out there. You just kind of have to find what works for you and go from there.
Well, it's about 12:50, so I think I might actually kind of end it there because I know many of you may have questions for our panelists if they have a few minutes to come up and say hi individually, and also want to give them a chance to have a piece of pizza if they haven't had one yet. So, and for myself, I'm getting a little hungry up here. So, so I'll end it there, and I hope you can all join me in thanking our panelists for their time today.